recursion is a very efficient, important solution to solve programming problem. You will see a lot of recursion approaches in future. Recursion first came from math. In math, recursion means a solution to a problem that is defined in terms of simpler version of itself. For example, factorial n can be represented with factorial n minus 1 times n. Another example is Fibonacci number n can be defined as Fibonacci number n minus 1 plus Fibonacci number n minus 2 together. In programming, recursion means a method or a function calls itself. That is a very important element for recursion method. In this example, you can see inside the method f, there are two method calls fn minus 1, fn minus 2. In the else part, normally in recursion method, you should have a base case. For example, in this example, if part, if n smaller than 3, return n, that is the base case which stops the recursion. How to write a recursive method? The first step, you have to take a problem and break it down into identical but smaller problems. You just do it in such a way that eventually the smaller problems become very trivial to solve. Those are the base cases. Once we have analyzed our problem in this way, we can write a method that checks for and solves the base case, which is really easy. Otherwise, just calls itself on smaller problems. There are a lot of similar examples in our real life. For example, searching meaning of a word in dictionary. We can divide a dictionary into two halves and then to try to find the middle page contains the word or not. If no, either go the first half to, to follow the same way or go to the second half to search the meaning of the word. Another example for for a big project. In order to finish the big project, the big contractors need to distribute the contract to smaller contractors. Recursion is the approach of divide and conquer, but we divide the problem into smaller identical problems. One good example is searching a word meaning in the dictionary. One approach is to do sequential search. We just go through the first page, second page. This way is lengthy efficient if the dictionary has many pages. Normally, we just open to a page very close to the middle. Such way, we divide the problem into two smaller problems, and we check the word is on the page we open to or not. If it is, and we just retrieve the definition from the middle page, which is the base case. If this is only page in the dictionary, and we said the word is not inside the dictionary, that is a second base case, failure base case. Otherwise, we just determine which half of the dictionary contains the word most likely, and then we just recursively on that half as we are solving the problem for whole dictionary. You can see there are four questions we need to answer in order to solve a recursion problem. First, how can we define the problem in terms of smaller of same type problem. Second one, how does such recursive code diminish the size of problem? Third one, what instance, what case of the problem can serve as the base case? Last one, when the problem size is decreasing, we can reach the base case or not. For the dictionary problem, we can write the following pseudocode. If dictionary contains only one page, we will check if that page contains the meaning of the word or not. If no, that's it. That is the failure case. If it is, we just retrieve the meaning of the word. That is another base case. Otherwise, we just open a page near the middle, determine which half contains the word. If the word is in the first half, and then we just do the same thing, searching first half for the word. Otherwise, search the second half for the meaning of the word. We just check carefully those four questions. How can we divide the problem into smaller identical problems? For dictionary problem, we just divide the dictionary into two halves. Once we divide the dictionary into two halves, we can use the same strategy to search for the appropriate half. Second question, how does each recursion code diminish the size of a problem? Certainly half of dictionary, the size is decreased. Next question is for the base cases. For the dictionary problem, certainly if the dictionary contains only one page, that is the base case. Either the page contains the word or not. So there are two base cases. One, we can find the word. Another one, failure case. The word is not inside the dictionary. Last question. When the problem size decreases, can we reach the base case? Yes, for dictionary, we divide into two halves each time. So certainly at one point we'll reach the dictionary which contains only one page. Now we will write the second draft of the dictionary solution. So the search method accepts the two parameters. One is the dictionary, another one is the word we are looking for. If the dictionary contains only one page, we just scan the page for the word meaning, which is the base case. Otherwise, we just open the dictionary to near the middle and then determine which half contains the word. If word in the first half, and we search recursive code on first half of the dictionary. Otherwise, we search for second half of dictionary. From this solution, you can see there are two recursive method calls, and each time each call, the parameter has been changed. At the beginning, it's a whole dictionary. Now, only half of dictionary. So that makes sure that the recursion can stop. Based on this solution, you can see the recursive solution is more efficient than the iterative solution. This method fits the model of recursive solution. First, we can see this method code itself inside the method. Second one, at each recursive call, the value of page diminished by half. Number 3, the base case occurs when the dictionary contains only one page. Number 4, if there are pages in the dictionary, the base case is always reached. Let's summarize the four criteria for recursive methods or functions. Number one, method should call itself. Second one, each method call will solve a simpler, smaller, but identical problem. Number three, there should be a base case which is handled differently from other cases, which allows recursive code to stop. Number four, each time the method call will solve smaller problems, the size of the problem diminishes and ensure that base case can be reached.